welcome to Class Connect study series with Yusuf Arikewuyo. In our last class, we were able to examine the velocity time graph. We recall that the velocity time graph is a sketch or a pictorial representation of the description of the motion of a body. From the velocity time graph, we can get salient information about the journey or the motion of a body. Some information we can derive from the velocity time graph include the time taken to cover the entire journey, the distance covered, the uniform speed or uniform velocity, the retardation, as well as acceleration and other relevant information. Today's lecture shall consider some work examples on the equation of motion. That is, we shall be applying the equations of motion to solve some related examples or questions. To start with, let's consider this question. A particle starts from rest and moves with a constant acceleration of 0.5 meter per second square. Calculate the time taken by the body to cover a distance of 25 meters. In this particular question, the first thing we need to do is to identify the given parameters, as we shall see as follows. So that we have given the initial velocity to be 0 since the particle is starting from rest. We also have that the acceleration of the particle was 0.5 meter per second square, and it covered a distance of 25 meters. So we were told to find the time taken to cover the distance. So we denote time with letter T. Then all we need to do is ask ourselves, from the four equations of motion, which of the four can we obtain T using the three parameters given? As a recap, we know that S is equal to U plus V divided by 2 multiplied by T as one of the equations of motion. Also, we know V equals U plus AT, and we also know that V square is equal to U square plus 2AS. And lastly, we have that S equals UT plus RAT squared. Considering the four equations of motion, it is evident that in the first case, S equals U plus V divided by 2 multiplied by T does not include A, and as such we can't use the equation. Also, in V equals U plus AT, we also have that S wasn't included, and in the third equation, V square equals U square plus 2AS, we don't have T. And from S equals UT plus RAT square, we find that we were given U, and U is also represented in the equation of motion. A is also there, and S as well as T. And as such, we shall apply S equals UT plus RAT square in solving our question. Thus, substituting the parameters in S equals UT plus RAT square, we shall have that 25 will be equal to 0 times T plus R multiplied by 0.5 can be written as 5 divided by 10 multiplied by T squared. So that we have 25 will be equal to 0 plus 5T squared over 20. And this gives, let's take a new slide, 25 will be equal to 5T squared divided by 20. Since 0 plus 5T squared divided by 20 gives 5T squared divided by 20. And if we cross multiply, we have 5T squared equals 20 multiplied by 25. Dividing through by 5, we shall have T squared equals 20 multiplied by 25 divided by 5. So that T squared will be equal to 20 multiplied by 5. Since 25 divided by 5 will give 5. So that we have T squared equals 100. If we take the square root of both sides, we shall have that square root of T squared equals square root of 100. And square root of T squared will give T which is equal to square root of 100 is 10. And as such, the time taken to cover the distance of 25 meters is obtained as 10 seconds. Also, let's consider this question. The motion of an object moving in a straight line is uniformly retarded so that it comes to rest in 20 seconds after traveling a distance of 40 meters. What is the initial velocity of the body? In this particular question, we are told to find the initial velocity of the body. This question is a question that represents the fact that the body was already in motion and after a period of time was brought to rest. It therefore means that the initial velocity will be greater than the final velocity, since the final velocity is going to be the rest velocity, which of course is 0 meter per second. So what we need to do now is to substitute the parameters in the relevant equation of motion. But before we do that, we shall identify given parameters. From the question, we were given that the time taken was 20 seconds, the distance covered was 40 meters, the final velocity was 0 meter per second since the body was being brought to rest. So we were told to look for the initial velocity of the body. Now, considering the equations of motion, the equation that can be used to solve this particular question is the first equation, which was given as S equals U plus V divided by 2 multiplied by T. From this particular equation, we have that S equals 40. By substitution, we have 40 equals U, that's what we're looking for, plus the final velocity 0 divided by 2 multiplied by 20. And of course, we shall have 40 equals U plus 0 multiplied by 10, since 20 divided by 2 will give 10. Let's take the new slide. So that we have 40 will be equal to U plus 0 multiplied by 10 as we obtained earlier. And we have 40 equals 10U. Since 10 multiplied by 0 will be 0, and 10U plus 0 will give 10U. Dividing both sides by 10, we shall have 40 divided by 10 equals 10U over 10. And this gives us U equals 4 meter per second. That means the initial velocity of the body before it was brought to rest was 4 meter per second. Let's consider this question. What force is required to cause a body of mass 10 kg to accelerate uniformly from rest across a smooth surface to a velocity of 50 meters per second in 10 seconds? To do this, we shall identify the given parameters from the question. From the question, we're told to obtain the force that will make the body at rest to attain a velocity of 50 meters per second. We are given the mass of the body as 10 kg. The initial velocity was 0 meter per second since the body was at rest. The velocity we need to attain, which is the final velocity, 50 meters per second, and the time is 10 seconds. But we need to know that force is obtained by multiplying mass and acceleration. But from this particular question, we were not given the value for acceleration. But by definition, we know acceleration is the rate of change of velocity. That is, acceleration A equals V minus U over T. And of course, substituting, we shall have A will be equal to 50 final velocity minus 0 initial velocity divided by time, which of course is 10. And of course, we have A will be equal to 50 divided by 10. Acceleration will be obtained as 5 meter per second square, such that we obtain the force required from F equals ma to be F will be equal to the mass of the body was given as 10 multiplied by acceleration. We obtain that as 5, which now will be 50 Newton. Therefore, a force of 50 Newton is required to make the 10 kilogram mass move to attain a speed of 50 meters per second in 10 seconds. Thanks so much for watching. Hope to see you in our next class. And please do not forget to subscribe and click on the notification button. Thank you.